what we want to do is find the critical numbers, determine where it's increasing and decreasing, find the second derivative and find the inflection points, and also determine where it's concaving up and down. And we're gonna put all that information in a single box.
Single box.
Okay, that's what I want to show you.
Oh,
Okay, and it's very important that you organize that, and then because we got to put that together, and then we got to actually sketch it after. Okay, so this is relatively not super bad. Like it's a relatively easy one. So first derivative, you get 2x, x minus 1 minus x squared 1, x minus 1 squared, right? 2x squared minus x squared, so that's x squared minus 2x. Okay, so from here the critical numbers are, they're 0, 2, and negative 1, right? Because it's undefined. But I already know from here x equals 1 is vertical asymptote, right?
Yeah.
So I don't need to consider it.
Okay.
Like if it's a vertical asymptote, it's a vertical asymptote. It's not going to suddenly become a cusp or one of those things. Okay. Second derivative. Okay, so you get 2x minus 2, x minus 1 squared minus x squared minus 2x, 2x minus 1. Alright. What can we factor out here? We can factor out x minus 1. Ooh, we can actually factor out, no, just x minus 1 and a 2. Let me clean that up. This actually becomes that. That's what this becomes. This is, you can factor out x from here and you get x minus 2, another 2 at the front. So we can at least factor out 1x minus 1, which will cancel out with the x minus 1 at the bottom, to give you x minus 1 squared minus 2xx minus 2. Okay. What is this? This is factor out the 2. X squared minus 2x plus 1 minus x squared plus 2x. I mean, if I'm making a mistake. Gone.
Isn't it 2x squared?
I factored the 2 out the front here.
Oh.
Okay. So that's gone. That's gone. That's actually pretty nice. We only have 1 left on the top. So we're going to be 2 over x minus 1 cube, right? So does it going to have any inflection point?
No.
Right. Right. It doesn't equal to 0 anywhere, right? Okay. So let's pull all that information together. Okay, as I said, we want to do that. Here's what we do. Now we use a box. Okay. I'm going to put the first derivative information here and second derivative information here. All the critical numbers, you put it in the order. Okay, you put it in order. We start from minus infinity to represent the number line. Next critical number is 0, and then it's 2, right? And then of course there's some numbers in between up to infinity.
Oh, this is like a sign chart.
It is, yeah. Okay, so sign chart that you've done before, you did with each individual factors.
Yeah.
Here we're doing it first and second derivative, right? So here it's gonna equal to 0 here. Now let's do a quick analysis. No, you don't need to plug in numbers. The bottom is always positive because it's squared, right? So the first derivative being positive only depends on this. This is a parabola that with roots is 0 and 2. So where is it positive? Like that, right? This one here is cubic.
Oh.
So it's positive when x minus 1 is positive, right? So, you know what? We should actually put 1 in here. Vertical asymptote is pretty critical. Like there's something drastic happening on the graph. Critical numbers are just saying like there's something drastic happening in the graph. Okay. Sorry about that. It's a little bit skinny in there. I gotta squeeze it in there. Okay. Okay, so it's positive here like this. Oops. Positive here like this. and it's negative here, right? Okay, so that's it. That's what I want you to draw. The next step is to see that this means it's going up and it's concaving down, so it's doing this. It's going, this is negative, right? Here?
Yep.
So it's going down and down, so it's concaving like this. Here it's concaving like this. Here it's concaving like that. So we can see the actual shape of the curve, right? We can find the points at 0 and at 2, right? Well, 1 is a vertical asymptote, right? To anchor it, to stitch together a graph. Okay, that's what we're gonna do. But for now, I want you to just draw this box completely.